Hello everyone, my name is Zhang Qihang. Today I will present the first part of our final project. Our project title is Hands-on Comparative Analysis of Open Science Security Test Tools. In this project, we tested one vulnerable web application. The application is called a Wasp Joyous Shop. Our group used three tools: Subgraph, a Wasp zip, and a Trophy. I will mainly explain the project background, the target application, the tool selection, and the subgraph SAST part. It is an intentionally valuable web application. This slide shows our project scope. Our target application is a Wasp Joyous Shop. It is made for security learning and testing, so it is safe and legal to use in the local environment. We only tested the application on local computer. We didn't test any real public website. In this project, we need three testing methods. The first one is SAST. It checks the source code. The second one is DAST. It checks the running website. The second one is SCA. It checks the available dependencies. This slide explains why we choose these tools. First, subgroup was used as the SAST tool. It can scan source code and find unsafe code patterns, such as SQL injection and if-evil. Second, a Wasp zip was used as DAST tool. It scans the running web application and checks the HTTP register response and security headers. Third, Trophy was used as SCA tool. It scans dependency files such as package gesture and package log gesture. This slide shows our testing process. First, we download a Wasp Joyous Shop to local computer. Then each tool tests this differently. Subgraph sends the source code, Zip sends the run website, the localhost 3000. Trophy sends the dependency files. After scanning, we saved the results. Then we manually checked some findings to see if they were true positives. Then we compared the three tools to direction results, coverage, and ease to use. This slide is used about subgraph part. Subgraph was used as the SAST tool. I ran it in Jupyter Notebooks on a local machine. The result was the subgraph 11680. Then I downloaded the Wasp Joyous Shop source code. I used the Wasp top 10 real set to scan the source code. The result was saved as a subgraph result gesture. It was also converted into subgraph finding CSV, so finding were easier to read. This slide shows the subgraph result. Subgraph found 32 findings in total. In error 17 manual and 2 manual findings. I select 5 findings in manual checking. They include SQL injection, evil injection, open reject, and directory listing. Most of them were true positives because they match the risky code parties in source code. Overall, subgraph was useful for finding source code level security problems. That's all for my part.
This slide shows our DAST testing with Wasp AP. DAST tests the running website from the host like a real. We use the Wasp AP version 2.17.0. The text with the log juice shop set at the localhost port 3000. We used the filter policy with both the traditional spider and the AJAX spider. On the right is a risk summary. The AP found no high-risk alerts. It fought for median alerts, 1 low alert, and 1 informational alert. So the main problems are median level communication issues. I will explain them next. This slide shows the ZAP findings. Most issues are about headers, queries, and HTTP configuration. The medium risk ones are CSP header no set, CSP no fallback, HTTP only set, and queries misconfiguration. There is also one low-risk issue, Unix timestamp with resembling responses. We also did a manual review. Most alerts are likely true positives, but the HTTP only set needs confirmation because our log lab may use HTTP on purpose. The screenshots on the right show the CSP and the queries evidence. Thank you.
For this part, I used the Travis as a software computation analysis tool, and the Travis was used to scan the juicy shop dependency files and the mini package.json and the package log.json. And before scanning, I generated the package log.json file to make the dependency tree more completed. And then I checked the Travis version to run a file system to scan on the local juicy shop and folder. The scan result were saved as the JSON and the text files for advanced and later analysis. And about this slide shows the main Travis findings. The Travis found the 17 issues in total, including 5 control and 36 high and 25 medium and 4 low. And findings, most of these issues was related to vulnerable one third party packages. And for example, the capital.json and JSON and broken and lost, and the multiple had the control vulnerabilities. And I manually checked the package log.json file and confirmed that these vulnerable packages and versions rarely existed. So selected the control findings we treated as the true positives. The site compares these tools, and the sample is the SAST tool, so it checks source code and configuration fields. The API is a DAST tool, so it tests the running juice shop website. Travis is an SCA tool, so it checks 3-party dependencies. Each tool has different focus. And SAMSCAP is used for during the code review. The AP is used for before releases. The Travis is used for dependency management. And the main point is that these tools should be used together. Each tool also has limitations. The SAMSCAP can find the risky code patterns, but it may not prove whether the issue can really be exploited at the runtime. ZAP can test the running website, but it may miss the logic-based function or the business logic problems. The Travis can find the vulnerable package, but it cannot test the XXS and circle injection, access control, or the checkout logic. So one tool is not enough. A better approach is layered testing with SAST, DAST, and SAE. From this project, I learned that the security testing needs more than one tool. SAST, DAST, and SAE shows different types of risks. I also learned that the tool results need the manual checking. A high survey finding does not always mean it is directly exploitable. The good advance is also important, such as the screenshots, raw output, SCV files, and the reports. In the real project, these tools can be added into the CI/CD to improve the security before release.